All right. So as the title of this panel suggests, we're talking about artificial intelligence, attacking, but also defending. So the first question that I want to start off with is, how much is artificial intelligence now being used to attack networks or applications? And also, are attackers and the methods of attacking, are they becoming more sophisticated?
I think when we first came on the market with Darktrace in 2013, we really saw mainly things like credit card theft or maybe the occasional, defacing of a website. A few years back, we of course saw the DNC hack in the United States, and that moved to what we'd like to call trust attacks. And that's where really the attackers were trying to get people to lose trust in democracy. In terms of the types of attack we most recently saw, things like WannaCry, Petya, NotPetya, and those were really kind of machine-based attacks in that they moved at machine speed. They used things like worms to spread very quickly through networks. In terms of AI being used, the one time we have seen AI was actually an attack about 6 months ago in India. It didn't actually have any malicious intent that we could tell, but rather what it tried to do was use a form of machine learning to just learn and blend into an otherwise noisy network. We have to think that might be a form of maybe cyber espionage, where really the intent is to use the machine learning just to go undetected for as long as possible.
Mm-hmm. Mm-hmm. So Joseph, are attacks getting more sophisticated? And so, Nicole mentioned the use of worms with Petya and WannaCry, but worms and things have actually been around for quite some time.
Yes, they've been. I believe when it comes to artificial intelligence, one thing that I want to mention, there are different ways to classify every subject. You can speak of intelligence. You can speak of human intelligence versus artificial intelligence. Or you can classify it in a different way. You can speak of, civil society intelligence versus military intelligence, although people say that there is no such thing as military intelligence. Or you can speak of business intelligence versus security intelligence. And I believe that in the context of our conference here, of our audience here, we should speak of security intelligence. And the first thing we should be doing is defining security intelligence and dispelling some myth that exists around it.
So yes, what is security intelligence by your definition?
I will draw this analogy, the very unfortunate analogy, and I believe people do it very often. They draw analogy between business intelligence and security intelligence. And business intelligence is all about data collections and data analytics. So you collect information in enormous amount of this data. You collect them continuously from all different business sources. You collect them in huge repositories, and then you do analysis. And at the very end, you come up with the best business decision. For example, you understand that you should sell this product in city A, not city B. Try to do the very same thing with security intelligence, and you will fail miserably. You can collect all possible information in the world. You can do it continuously, get information from web application firewalls, network firewalls, IPSs, endpoint protections, collect it, do analysis, and then you would come up with the best security strategy or practice. But by the time when you come up with that best security decision, you well might be dead under attack, or your money will be stolen, or your identity will be forged, or your website defaced. The point I am making is that security intelligence is not about data collection and analytics. Yes, you have to use them, but the most important thing about security intelligence is not dealing with data, because data is passive, data is impotent. The most important part of security intelligence is protection. Security intelligence should offer a solution to protect systems in real time.
Interesting. But Nicole, how do you respond to that? Because Joseph's point there is that we shouldn't necessarily be analyzing data, but that's kind of how your solution is working, isn't it?
Well, I think what's interesting is there's all different styles of machine learning and artificial intelligence. And there would, we have seen approaches where people try to take machine learning and analyze all past data for past attacks. And while you could use machine learning for that purpose, it really isn't much better than what we've seen for the last 2 decades of signature-based approach, right? Yesterday's attack on someone else isn't necessarily a predictor for tomorrow's unknown attack or insider threat. So, in our case, what we found was using self-learning, unsupervised machine learning, to do exactly what you're stating. You need to look at raw network traffic in real time, not historical logs, not yesterday's attack. You need to look at real-time network traffic and understand what's normal for each user and device and what's not normal. And so that, I agree to the extent that you've got to move in real time when it comes to security and especially to using AI approaches for security.
And I would agree with Nicole that it is important to collect information, but that's not what I was saying. I believe we have to, with defining security intelligence as ability to protect, the next step is what are you going to protect? Your network, your endpoint, or your application?
I was going to ask about that because we're talking about networks, but then when we look at WannaCry and Petya, I mean, the reason that they were able to succeed was not necessarily because of a problem with the network, but it was a problem with the application, with the fact that the people did not patch their Windows installations.
That is exactly. It's your me who is that? You're right. If you look at the most reputable firm that does analysis in IT space, Gartner assesses that about 75% of all attacks target applications. And there's a good reason for that, because application is the heart of our environment, of our life. They manipulate our money. They run our data. They run our industries, our governments. And that's why hackers attack application. So my point is that because the main vector is application, main vector of attacks, you have to be able to intelligently analyze and protect applications. My problem with network is that, yes, you can collect analysis, you can do it in real time. The problem with the network is network does not see or cannot see applications, and applications are most important. Application analyzes traffic to and from applications, but it has no insight whatsoever into the most important, into application itself. It cannot see data flow inside the application. It cannot see logic flow inside the application. It cannot see how application opens the database, retrieves data, and processes it. It even don't know that application is not the one application. They're seeing, the network sees only the web interface. They cannot understand there's actual multiple applications talking to each other with one single interface. It's a black box for the network. The network technologies, network security cannot understand application. How can you protect something that you cannot see and cannot understand? So the solution that I'm planning at my time to talk about is, yes, intelligence, but inside applications.
Nicole, how do you want to respond to that?
So I think that with applications, and the reality is we need to secure applications, we need to secure networks. When the attackers really try to get inside, they're trying to get into the network, and there's going to be many applications inside that network. There's going to be many devices connected to it. And a lot of times it's not just the traditional servers and enterprise applications, but what about things like IoT devices? In fact, normally when Darktrace drops in a network, we always ask the security team and the IT team, well, how many devices and people are connected to this network? And on average, they underestimate it by 25 to 30%. And a lot of the types of things they're forgetting about. They're forgetting about everything from people walking in with smartwatches, but also things like internet-connected vending machines, internet-connected cappuccino makers, never mind things like LED lighting systems, HVAC systems. So there's a number of IoT devices connecting to our networks, even in the enterprise. And we need to be able to see and model all of those. Because just like attackers used to get in by going through the printer 5-10 years ago, now the printers are secure, but these IoT devices aren't. And so that's now the low-hanging fruit. That's now the attack vector of choice for the attackers, is come in through the IoT to get to the enterprise network.
Well, that's interesting. So, but it's still using exploits, or are we talking about just 100% completely unsecured devices? Because I mean, security experts have been warning for years. I mean, first it was the printer, now it's cameras and these other IoT devices. But experts have been warning for years that we need to secure them, and somehow they're still not being secure.
That's right. I think it's not just about the manufacturers trying to secure the device itself. It's actually about the communications between those devices and the network. So that's where we see the vulnerabilities. And also you just have a lot of vendors who are rushing IoT devices to market because they're all funded and they're all competing in their various markets. And so a lot of times they rush it to market without security, but it's beyond just securing the device, it's securing the communications. We've seen lots of attacks on everything from video conferencing equipment, voice over IP phones. I mean, you name it, it's just those are the easy way to get in because they're not protected from traditional methods.
Yeah, and it also raises a pretty big question because, I mean, we're talking about security, whether it's application layer or network layer security. At the end of the day, the weakest link in the chain is still going to be humans, whether they're developing IoT devices or perhaps they're victims of social engineering. And so when you guys are looking at that in terms of security solutions, I mean, how big of a threat do you find human error, perhaps, or just insiders? Joseph, you want to answer that?
Well, I believe the question more or less is whether attacks are more sophisticated and people, well, make mistakes. I believe that attacks maybe remain the very same ones, but people are not doing enough to protect their systems, applications in my space. For example, you're familiar with attacks such as SQL injection that can retrieve all data from your database, or cross-site scripting that takes control over your browser, or cross-site request forgery that retrieves money, transfers money out of your accounts. They've been known for, 15 years? And you know what? We conducted research. We analyzed 300,000 applications. The rate of SQL injection and cross-site scripting is the very same as it's been 15 years ago. It's not that attacks are more sophisticated. It might be very stupid attacks, such as these ransomware attacks. It's people that keep making the very same mistakes and not creating good enough systems and not testing them and rolling them into production. So it's human error, yes, but it starts not at runtime. And, well, we somehow expect that at runtime we can do many things. But it starts with the development of the system. People don't create this system secure. That is a mistake.
But I think, though, it's we see human error all the time, and it's not only malicious intent. Sometimes it is accidental. It might be an employee, obviously, that clicks on a spear phishing link or falls for a social engineering attack. But we also see sometimes even privileged users, the system administrators, the network administrators, the people that know the systems and networks inside and out. In fact, we've actually seen several attacks where we've seen network administrators using the infrastructure in their own companies to mine or manufacture Bitcoin after hours as just another way, to make some extra income. But we also see, maybe a system administrator doesn't want to drive into the office at 2 a.m. to fix something, and so they just, connect their home network to the corporate network, and now you've got a backdoor into the network.
Mm-hmm, mm-hmm. So we're coming a little bit close to the end of our discussion, unfortunately. But I'm curious, and so when we're looking, bigger picture here. So we talked a little bit about IoT, we talked a little bit about human error, but I'm curious in terms of vertical or industry. I mean, what would you say is the most vulnerable industry, or another way to ask that question perhaps is what's the most threatened, what's the most targeted industries that we're seeing, and has that changed much in recent history? Joseph, you want to try first?
Well, the most targeted industry by hackers has always been the industry where money is financial industry, and over the last several years we see government being attacked. So these two industries, financial and government, they are primary target to attacks. By the way, we made a comparison from the viewpoint of vulnerabilities that developers in these industries built inadvertently in their software, they're pretty much on the same level. Governments is a little worse, but there is no good industry that actually does good work in creating secure systems, secure applications. But the most suffering industry, financial, and then the government.
Yeah. Yeah. Nicole?
Yeah, I mean, the reality is all size companies, all industries are really come under attack. I don't know that one industry is necessarily more under attack than another. We do see about a quarter of our customers are financial services. We have a lot of customers in telecommunications, technology companies, but also industrial control systems. We can't forget about those. So do a lot of work in things like energy, alternative energy, water supply, travel, transportation, and of course retail and e-commerce.
Mm-hmm. And do you agree with what Joseph mentioned earlier, that we're seeing, it's across the board, there really isn't any really good examples of an industry or companies doing a good job with securing their systems?
Well, I think one area that's been very promising, in general, hospitals and healthcare have been behind the curve, but within the healthcare industry and biotech, we've actually seen a lot of promise. For example, genomic information protection for medical research, that's been kind of an early adopter segment.
Okay. Okay. And so I mean, again, so looking at networks versus applications. So I mean, what's the one thing that enterprises can do right now to actually secure their system? I mean, maybe Joseph, is it just upgrading their Windows system, or is it employing a company like Darktrace?
Question for me?
Yeah.
Two things that they should be doing when it comes to securing applications. One, testing applications hundreds and hundreds of times before deployment along your development process. Every piece of code that you develop should be tested with static analysis. Every running application in test mode should be tested. Do it hundreds of times, test it before deployment, make sure that you, to the best of your knowledge, you developed a secure application. And when your application is up and running, that is where that security intelligence comes, its most recent incarnation, security built into runtime environment. There is a new technology called RASP, Runtime Application Self-Protection. It's technology, look it up. There are vendors that offer this technology. It instruments, it gets seamlessly, intelligently injected into your Java virtual machines, into your .NET CLR virtual machines. It becomes a part of a runtime environment. It has insight into every piece of data coming into application. Every instruction, every method being executed, it can see whether it's an attack or benign access, and it can stop attack in real time by simply not executing that attack. So this is the newest thing of intelligence that protects. It really stops physically attacks against applications.
Well, great. Well, unfortunately, we're out of time, but Joseph and Nicole, thank you so much for taking the time and sharing your insights with us.
Thank you.
Thank you.